Earth's dynamics, continent building. The crust structure of continents. Most of the highest elevations of continents are located near the edges. What do you think that is? In contrast, the interiors of most continents are flat. Usually, the middle of a continent is only a few hundred meters above sea level. Continental interiors have very few mountains. In these regions, the rocks exposed at the surface are old, igneous, and metamorphic rock. The interiors of continents are usually smooth and flat because of millions of or even billions of years of erosion. How continents grow. The shapes and sizes of Earth's continents have changed many times. Continents can break up and get smaller. They can also get bigger. Continents can get bigger when erupting volcanoes add igneous rock. Another way continents get bigger is through the movement of tectonic plates. Tectonic plates can carry island arcs. Whole continents of fragments of continents with them as they move. When plate-carrying fragments reach the continent at a convergent plate boundary, the least dense fragment gets pushed onto the edge of the continent. Fragments added by tectonic plates have increased the size of the west coast of North America over the last 600 million years. The dark areas in the map shown above parts of the present day. North America that was once attached to continents in other parts of the world, fragments in the western United States including volcanic arcs, ancient seafloor, and small parts from other continents. If rock were not being added to continents, what do you think would happen to the size of continents? Everything would change their size and shape. Weathering and erosion gradually would wear them down. Continental interiors. Rocks in continental interiors tend to be stable, flat, very old, and very strong. They are usually more than 500 million years old. In some interiors, the rocks are much older than that. Some rocks in Canada are more than 4.2 billion years old. These rocks might be the oldest on Earth's surface. Formation of interior plains. A plain is an extensive area or level or rolling land. The interior plains cover most of central North America. The rocks in these plains came from collisions of several smaller plates. About 1 billion years ago, at different times in Earth's history, shallow seas covered the plains. Millions of years of weathering and erosion have flattened the plains. Formation of basins. Just as plate motion and isostasy create mountains, they also can cause subsidence. Areas of subsidence and regions with low elevation are called basins. Sediments eroded from mountains build up in basins. Under the right conditions, the remains of plants and animals are buried in the sediments. They build up in basins. Over millions of years, heat and pressure convert the plant and animal remains into oil, natural gas, and coal. Sedimentary basins are the source of most of the energy resources that humans use. The world's largest oil and natural gas fields also lie in sedimentary basins. Basins can have great economic importance. Formation of plateaus. Some flat regions are high above sea level. Flat regions with high elevations are called plateaus. Some plateaus form through uplift. The Colorado Plateau, shown on the map below, is an uplifted plateau. Uplift has raised the region by more than 1 kilometer in the last 5 million years ago. Notice on the map that the Grand Canyon is only a small part of Colorado Plateau. The Colorado River formed the canyon as it cut through and eroded the uplifting plateau. So the Grand Canyon was created by water. The flow of lava also can form large plateaus. More than 200,000 kilometer of lava flooded the Columbia Plateau over 2 million years. Multiple rock flows built up layers of rock. In some places, the plateau is more than 3 kilometers thick. Dynamic landforms. When you started reading this chapter, you might have thought that Earth had always looked the same. Now you know that Earth's surface is constantly changing. Mountains form only to erode away. Continents grow, shift, and shrink. Nothing stays the same for long on dynamic Earth.